Okay, welcome everybody. If you're here for the session like it's on the screen, transforming your team using DevOps, then you're in the right session. If not, you can change room, no problem. You can change room whenever it gets boring, it's also no problem. Welcome everyone, also the people online. Today I'm gonna tell a story, real world example in my days as team lead, leading a team that had to manage these databases. Because in the picture here, you see databases. Because every circle is a database, and every line is a dependency to the database. So we're talking here a brownfield project, not a greenfield, not a new project, no. SQL Server databases on-premise that are over there for a decade, some of those databases. But with all the projects going on, the team had to change. The team had to change using their processes. The team had to change looking at the people, what are we doing and how can we change this? But first, if I look at this, it reminds me actually at a Ferris wheel. It's a Diabelski Mullen. I practiced all night. So I had to look up a picture to find one in this city, and this is the. This is not always there. It's not there in the winter, but it's there in the summer, as I've been told by Google. So I think you can see the resemblance. Okay. So this is what we're going for. Everybody still in the room? Online people already dropping off or still there? Okay, still there. Good. But before we start, I would like to thank all the sponsors, but without the sponsors, this event isn't really happening. So thank you, sponsors. And then a little slide about me. My name is Tonie Huizer. That's in Dutch. I'm from the Netherlands. But the international name I go by is Tonie Huizer because it's better pronounceable for most of you. I'm a freelance DevOps consultant. That means that I'm working in a small, privately owned consultancy firm, and I like to do DevOps projects. I do some data projects, I do some software projects. I write articles, and I write articles for Redgate Software, and for them I'm a community ambassador. I'm not a DBA, I'm not an engineer, but I work with all those people, and I work in between the teams. And what I like in my work is people and technology and the combination of that. And I also like whiskey, but that's a hobby. And I don't think my wife is tuned in, so it's business. Yes, of course, single malt, yes. Single malt whiskey, yes. Or else it's not whiskey. And recently, Peter, a Dutch friend of mine, and myself started a new conference called SQL. It's on the right-hand side. It's a combination of C and SQL because the conference is near the sea. And April 12th was the first time. And all the speakers or attendees that want to come to the Netherlands, I invite you for next year because next year it's going to be bigger and greater and with, of course, Polish speakers. So SQL. Look that up. If you want to connect with me, just scan the QR code or find me on LinkedIn. That's where I'm most active. But enough about me, because we're here for your expectations. We're here for the session. If you're here for a data ops session with moving lots of data into other medallion states and fabric and warehouses, you may leave now, because this is a team that's using DevOps on an on-premise C# solution, C# solutions. And every bit of pain we felt as a team transforming to a proper DevOps. And the reason for that is that we didn't really follow up with the 4 phases of DevOps. And that's our agenda for today. We're going to follow the 4 phases of DevOps. And if I don't talk too much, there's still room for discussion and questions. But if you want to ask a question in between, just raise your hands. I will repeat the question for the online audience, and then we continue the rest of the presentation. So let's start with the end goal, because the end goal our team is working to, or was working to, and is now using, is this. We want a proper DevOps that starts with the plan phase. And the plan phase means that every bug, every feature request, every piece of work we have goes into a big database called the backlog. And from that backlog, every sprint, we see what's the most important for the customer and put that on that sprint. And when we start a sprint, we work with developers, and this is a data conference, so I focus on the data side, but C# developers are also included. We work with developers that work on their own personal database. That means that there's no shared development database. That means that everyone has his own database. Every developer works on his own personal instance, personal container, or whatever. And that database is linked from day one, from the first start, to the work you're doing. So you have provenance in the end, when you deliver, where the work started from. And for that, we're using different technologies. So we're going to use a version control system, Git. We're going to use branching strategies. And we're going to use a technology to do provisioning, to get that database ready for you. And when you're done developing, then you create a pull request. And with the pull request, you're actually asking someone else in the team, review what I've been doing. And if it's good, and if it's tested, because the migration script will also go into the test pipeline, also a provision database that will be thrown away when the test is done. And only then, when the test is successfully done, then the pull request is closed, and the code you just been committing goes into the main branch. But the story doesn't end there. The migration script that comes out of this pipeline will go further down the pipeline to staging or testing or QA or whatever you're going to call that stage. And the same migration file goes into, where it is, production. And no one alters production, right? Well, they do. And that's why we're also drift checking this. So we went from the plan to the develop to the deliver phase, and now we're actually at the fourth phase of DevOps, and that's the operate phase. And in the operate phase, we do a lot of things, but one of them is checking if this production database is still in the same shape as the last time we delivered it. And if it isn't, we create a work item, and the cycle starts over again. So now I'm going to explain in the next, 15 minutes, how we did it. Everyone still with me? We continue. So, the plan phase. Where it is? Oh, sorry. It doesn't animate, but the plan phase. And everyone that works in data or the software has came across the famous quote of DevOps. I mean, everyone knows this quote, right? It's in every DevOps presentation. And it says that it's very important that you first look at your people, what are they doing, their processes, and then use tools to enable the best out of your people. And Donovan Brown, because that's the guy who said this, he's now retired, but he's the Microsoft DevOps guy, told me this, and it finally got to me in this conference. On this conference, there was another guy. He just happened to be in this room here, but I won't mention his name because it's Ground Fritchie. And he told me about cloning, but that's another story. But this is Donovan Brown. And here's Donovan Brown explaining what was wrong within the Microsoft team that developed Visual Studio Online, later called Azure DevOps. He was telling what was wrong within the Visual Studio team. And it came down to they didn't implement a proper DevOps for their own. So they didn't eat their own dog food. And if you zoom in a bit, this is me. Just happened to be in the picture, so it's cool to show here. But enough. So plan phase. Oh, here's the animation, sorry. So the plan phase. So Microsoft has on their website a list of practices. And the practices of plan are create a backlog. And the other practice Microsoft has on its website is use Kanban boards. And visualize the progress with dashboards. And above all, use agile techniques, use agile software development techniques like Scrum in your team. But if we looked at our team, we started with like this cardboard and little sticky notes, and then we transformed it to like this whiteboard with magnetic sticky notes, so magnetic notes, and we even got a new refinement in it, but it all didn't really work out. And the reason was not that we did it offline. That was not the only reason. There were more reasons. And one of the other reasons is that the team was just too big, because all the names here, or actually operations, are people in the team. And with too many people in the team, you cannot focus on what's really important for the customer that sprint. Another thing, there was no real fixed iteration path. There were no sprints. We're going to do it later, tomorrow, or today. That's the only timeline we had. And that seems pretty nice, but it isn't. Never, yeah. We should add one more column, is one of the remarks from the audience. Never. But because of the sizes of the team, different customers were handled by the same team. So the stakeholders couldn't really look into the team, because the stakeholders could easily be competitors, because we were serving external customers, and showing the backlog from another customer to this customer could be a problem. And this was a task. So you had to fix for the customer TBO issues, which is not really good refined, right? Because what are issues? I mean, I can tell you about my issues, but I think then the 40 minutes will be too less. So let's continue. And the last thing is actually the offline part. So because we're working offline, there was no integration with whatever we're going to develop, whatever we're going to deliver. So we had to change this. And for the demo part, I'm switching over to Azure DevOps, but it can be any tool, of course. And for the demo part, I'm using production, because testing in production is always the most fun. And for the demo part, we stay in Azure DevOps just to show you how the process works. Yes?
What do you mean when you say you were working offline?
So the question is, what do you mean with working offline? So in the old days, we were working like with this offline board. That's what I mean with offline. Yes? And we're now going to work online. So I'm turning my back to you because of this setup, but I still like you. Here we have a dashboard created in Azure DevOps. And it's just an example, and what you like for your dashboard is personally for you, but also for your team, because you can make dashboards for your own in Azure DevOps, but you can also make dashboards for the whole team. And for my example, which just got refreshed because of auto refresh, we got 3 tiles here with work items behind it that will show what kind of work is there and what kind of items are still open. So for example, on the right hand side, there's still one task that needs an estimate from a .NET developer. Here you see some work items assigned to me, but I'm already 3 or 4 sprints out of this team, so I don't think I will get this work done. So that's why work by me is empty at the moment. But another important part is the monitoring of build pipelines, release pipelines. We will come to that in a second, or not in a second, in a few minutes. Open pull requests, but also the success of pipelines. And we also come to the success of pipelines later on in this presentation. So this is an example of a dashboard. Another example, because we went from offline to online, we just needed to create work items. And this particular process within Azure DevOps has still the standard work item types, but you can change that. You can look at your team and see what's necessary for your team, what kind of work items and what kind of hierarchy you need, what kind of structure. So for the demo, I'm just going to create in production, but we're going to throw it away later, a work item. And the guys in the Netherlands know I'm doing this, so normally they don't mess with me, but let's call it like a test task. And this test task can be easily just tagged, and a tag is just another thing that's interesting to filter on later on. I'm just gonna get it to a customer and just keep the rest empty. So this work item will come back later on in the process. This work item will be the test work item we use for the rest of this presentation, because we're getting back to the presentation, because the focus really is not the technical part, it is really the process and the people part. So if you look now what changed, we changed it for 165 sprints and counting. I just updated it. The last time I gave this presentation it was still 150 something and still working. Like I told, I'm a freelance DevOps consultant, so I assume that if it's not working they call me, but you never know. Why did it work? Because we split up the team by end user, per customer. So we could get more focus and involvement of the stakeholder. People of the team got trained in Scrum methodology, and we have a better integration of tools. And above all, mandatory linking of work item. And what that means, we'll show in the next phase of DevOps. And I won't read them out all, but you can read it on the screen. All the DevOps practices for the phase plan of Microsoft, we can tick those boxes. And I just showed a little simple demo, but I think you can paint a picture further on. So, from plan to develop. So what was wrong with our team in the current develop phase? To decide what's wrong, it's good to look at what are the practices. And Microsoft also has on their website some DevOps develop practices. And the first one is really important. You have to choose a version control system, a VCS, that supports collaboration. If you have tasks in your organization, it's good. If you have a process in your organization, it's good. But automate those tasks whenever it's possible. Automate when they're repetitive. And another important part is turn your code, because SQL is also just code, into an immutable artifact. What that means, I will show you with some examples. We were still working with SVN in that day. So I'm talking 2019, 2020, something like that. And we had all the code in one repository. All code. And that made it very hard to work in parallel, because all code means all customers in one repository. It didn't make any sense, but none of us really got proper training in version controlling, so someone installed Tortoise SVN on the server and everyone just committed to that, and that's it. No branching, no nothing, no pipelines. And all releases were done, for example, for the .NET developer, just build it on your computer and copy it to the customer. No build pipelines, so what was really released was unknown. And the same was for the SQL Server. Just open SQL compare to the production database with the development database on your end, and release it. Don't save the scripts, because, hey, you might need it later. So the release code base was unknown. And, well, this one is obvious. With working that way, it's not really a good way to automate this. And the support for SVN within the community is also falling back. And this is an old picture, but it shows the support over the years between the different version control systems. And you see that Git was taking over. And it was 2020. And imagine how that number is now. So we had to switch to Git. We had to say, okay, what is this Git going on? We need to do this. How does it work? But we didn't really understand it at first. I will show you what I mean with that. So migrating VCS is one. But while migrating the VCS, while going to Git, you start learning about branching. But if you branch, you have to have a strategy. So you will branch the same as your teammate does. So you need to come up with a branching strategy. And within the branches and the build artifacts, etc., you need a naming convention, because naming convention makes it clear what something means. So first the migrating part. So we were migrating functional and technical. And functional because we first had to split up this whole big repository into different smaller Git repositories. And if you look at the .NET part, and again, it's a data conference, so I won't focus on that part too much, but the .NET guys were still using components that they copied from customer to customer. There was no NuGet feed, there was no DLLs to share, so it was really old school, just copying. So they had to separate the components and get pipelines for that as well. And technically, and here's the we didn't understand Git part, we migrated from SVN to Git to TFVC to Git again, which seems pretty strange, especially when you put it on a slide. But in those days, Microsoft advised to use TFVC. So you opened a new project, and the version control system within Visual Studio Online or Azure DevOps was TFVC. And the only way to get SVN into TFVC was follow a Learn Microsoft article to go from Git and then into TFVC. But the moment we touched TFVC, we thought, this is not what we're looking for. And then we migrated back to Git. So that's why this is a strange path, but that's the path we took. So how did it look? So what did we do? So the application source side and the database source side looked like this. So one big repository with all the projects per customer in. And all the databases were in one database repository for all customers. It was not really handy. So we were migrating, and I don't think it's good to see in the back, but it's just a repetitive story. Every project got their own Git repository. That's actually what this is saying. But also, for the database, every customer gets his own Git repository. Why no customer project, or sorry, why no repository per customer database? Well, that's because of this interdependency I've shown you in the first slide. And when you choose for this structure, you can have dependencies because everything is just in this Git repository. So that's functional and technical also. Now the branching strategy. So there are a lot of branching strategies. We focused on release flow. And again, this year, I showed the picture of, so it was 2018 or 2019, I believe, when I met Donovan Brown with the session. I also met another guy called Edward Thompson. And he was telling about the release flow, which was also used within Microsoft. And the release flow has short-living topics. And the main branch is always in release state. That means that whenever you pull your topic branch into main, it has to be tested, and it could be released anytime soon. And if you hotfix something, you always hotfix the release branch. And then cherry pick it back into main. This is the guy, Edward Thompson. He worked for GitHub, for Microsoft. I don't think he now still works for them. But there's still a nice article. If you scan the QR code, you come to a Learn Microsoft page more about release flow. We have a question.
Does this mean that you have a long-living main and also long-living release branches?
Does it mean we have a long-living main and long-living release branches? There's a one long-living main. Yeah, that's what it means. And I have a picture of that in the next slide. And the release branches are there, but it's a frozen state of main at the moment that you will release it. Yeah, like an archive, and which we tend to clean up every now and then. But if you look at from a technical side in Git, a branch is just a pointer at a specific commit, so it's never done. It's never gone. It's not just visible for your user interface. So your question is answered, I guess. And for the audience and for you and the people online, how does it look, this release flow in action? So this is your main branch going from left to right in the time. And whenever you start a new task, so this plan phase and branching development we saw in the slide number 2, you create a topic. And at this point, I won't bother naming conventions. That will be in the next slide. So we call it topic A. We do some work, we do some committing, and eventually we're done. We ask a colleague to review, we do a pull request, we do testing, and when the test is successful, we pull this branch into main. And from that point on, it can be released. So whenever the customer calls, and we're in sprint 97, the customer gets everything that's in main, including topic A. And time continues, we create a topic B, we do some work, we create a topic C, we do more work. Topic C is already done, tested, pulled into main, customer calls again, and it's the end of sprint 98, so we call the release branch sprint 98. And the world is fine, everything is good. But then topic B goes further, and we pull it into main, and then the customer calls. Fire! Something's wrong. Look at my database. Fix it, please. So the guys and girls that come in look at sprint 98, because that's the sprint release that was frozen, the state that was put in that branch at the moment the customer got it. And that sprint, that release will be fixed. So the hotfix will be pulled from release 98. And there will be some testing and some committing, and eventually this will go into release. But people that are paying attention, I see no one sleeping, so everyone's paying attention. This code will get lost if we don't pull it back into main as well. And if there's not that much change to the objects, there's one online question.
Yeah, we have a question from online, from a less technical question. How do you handle inconsistent or incomplete requirements, especially when they can be self-contradictory? What are your best strategies for tackling these challenges?
So it's more about the plan phase, so the refinement. So shall I repeat the question? So the question from online is, how do you handle incomplete requirements? That's actually a very broad question, and I think we have to cope with that every day, everywhere. So the team has a refinement day. So every piece of work that comes in will be pre-refined with the customer, and then later on it will be refined with the team. And when the refinement is not successful, it will never go on the sprint. And it sounds pretty easy, of course, to say it like that, but refining your items with the customer first and then with the team will process it within your head more and will challenge the other people to think about the solution. And eventually, or actually at the end, the customer still has to apply. But when the requirements are not done, you can't start working. But it's not always that simple, I know. So I hope that that answers the plan question from the online audience. I think they're like 10 minutes behind, but it's no problem. We will keep up. So we were at the tough question here. So where does the code go, Tonie, from this hotfix? So you have to cherry pick this into main. And sometimes it's just another pull request, and sometimes the object could be changed also in topic B, and then you really have to cherry pick this piece of code, this piece of SQL code, but also C# code, because this release flow is used for the .NET projects and for the SQL project. Okay, so this branching strategy was fine, but now we need names. Now we need consistency about how we are gonna call every branch that's made. So we came up a little bit inspired by what we found online, of course, and what we saw in other projects with, and I think not everything is readable in the back, so I will go from left to right. So we have branch category. Then, only when it's a hotfix, what release are we fixing? Ticket ID, so that can be an internal ticketing system or Jira or whatever that's linked to your Azure DevOps system. And then a free-form Pascal casing description where the developer could choose. So you can get something for the hotfix to start with the exception. Hotfix, fixing sprint 100. MMS is the internal ticketing system with a number. Firefighting, which mainly hotfixes are. Or you can get topic, again, with the ticket ID and my description. The only exception is the release branch, and the release branch is release and a unique identification. And this unique identification, we chose simply the sprint names, which was pretty easy because it will be sorted automatically for you. But you can also choose cities. But if you choose cities, choose them alphabetically, because Azure DevOps will sort them alphabetically. So if Boston, the city name, becomes before Amsterdam, it's sorted not the way you expect it to be. So choose your release branch wisely. So are we now better? Are we now following the DevOps practices for develop? Yes, we have one repo per solution. We can work in parallel, so we chose a version control system. And we're less time managing this version control system. And with the release branch, it's always visible what we released. But with all those checks, we can only check this one develop practice that Microsoft gave us. So we had to look further in our develop process. So do we have any repetitive tasks? Well, we had many, but I will only show you one. So before we went for the workflow I showed you at the beginning of the presentation, we were working like this. And so we have a shared development database, so no personal one. And because it's shared, every time a change will go from left to right, we have to filter it out. So we filter it out when it goes into version control, but we were not using branches, so we had to filter it out when it went to the shared test database, and we had to filter it out again because it was shared. So what I'm trying to tell you here is filtering out this change over and over again was one of the repetitive tasks we had. So changing to a branching strategy and changing to personal databases eliminated this repetitive task. So removing repetitive tasks doesn't always mean automate that manual task, because you won't automate this. The only thing you want is this sync script, which is basically your migration, which is your immutable artifact. You want that as once. So at the beginning of your process. And then, of course, automate repetitive tasks. And it can only be done, like just explained, with standardizing a process, use pipelines, and Azure DevOps has nice pipelines, GitHub Actions, whatever. Choose your favorite tool, but start all your automation locally, because it's very hard to debug a pipeline. And if you're like me, like to use PowerShell, use it, but use it as part of your repository. So put all your automation scripts in a repository and make that part of your pipeline again. And I come across pipelines where every bit of PowerShell is in line in the pipeline, which is not only hard to read, and I have to plug in my power IC, sorry for that. It's also not good because it won't show you any version of your scripts. So if you automate stuff, you also want that stuff to be in version control. Are we done then, Tonie? No, first we have some power. Yes, we're back. Use logging, a lot of logging. So when you go from local to your pipeline, still stuff breaks. And if it breaks, you want to know why it breaks. So start local, use PowerShell, but as part of your repository or an extra repository, and use logging. Demo. So this big repository, what went to one customer repository, is this one. And the customer is ESA, and DBS stands for database system. And all of these folders here are those databases that were interdependent in the first slide. And within every database folder, so we'll just open, for example, this one, we have migrations and we have schema model. And I'm using here Flyway, but it can be any tool. But I like Flyway. But I like Flyway, the desktop workflow, which means that I not only rely on migrations, I also rely on a snapshot of the schema model. And every time the schema model is changed, you will find, for example, I'm just going to open a recent, just going to open a table, you find the exact create script of the table. But if you look at the migrations, the first migration will show the create script, but the second migration will show you an alter script with a new column. But the schema model will always show you the state of the. So using the Flyway desktop workflow enables you to use both models. And both models is actually just a hybrid way of working. But I'm not here selling Redgate products because they're not even sponsoring this event. But this is recorded, right? Sorry. So next year you will find the Redgate booth, and we're there. Why I'm here at this page is I want to create a branch just to test it out. So I will create topic, and I will call it SQL Day 2005, and my Pascal casing is welcome. And here's the most important part. I will link it to my welcome work item I just made. And while this is just created in a millisecond, if I go to the other tab and refresh this one, you will see that a pipeline is kicked off. So even for just creating an empty branch, the pipeline is kicked off. Why? I need this build artifact because this build artifact is my entry for my database creation later on. And I want to work separately from all my colleagues, so I need exactly what is in the repository in an immutable artifact, and I need to go into my database environment. How immutable is this immutable artifact? Well, it's immutable in name only. Shall be honest with you, because if you have .NET code, you compile it to an executable. But if you have database code like SQL, you can compile, like we do here, to an artifact with only the migrations in it. And those migrations will be applied to a database. But it's still SQL code. So if someone comes in and alters it, it's no longer immutable. Luckily, Flyway will take care of that, and we'll see that someone is messing with the hash of the file, but it's not that immutable as an executable. While this is running, I can open it just to show you some of the automation that's going on here. And the automation is actually pretty simple because it's only copying, because the migrations were already in my repository, but I want them in this one immutable file. And I can also make a small example of what I meant with store all your PowerShell files which you use for automation in a separate repository. Every build of this database repository is also linked to this ADS automation tools repository where all my PowerShell logic is in. So every time I build something like this, and I will go a few steps back to open another one, which is done, you will see in my artifact that it not only contains, click it open, Tonie, you can do it. It not only contains the migration files we just saw, but it also creates a .automation folder with all kind of fancy, and I just open this one, creates clone images, PowerShell files. And those PowerShell files are used in the next phase of DevOps. Oh, we still have to check boxes, sorry. Check the box. We're using a pipeline to create an immutable artifact, and that artifact will go to all environments. And all those environments, that's the deliver phase we will see in a bit. So check all those boxes, checking my watch, and we go to the deliver phase. So, the deliver phase. This is where this immutable artifact will go down the pipelines automatically. So no more releasing from your computer, no more releasing from SQL compare comparing to your production environment. No, we want this automated so we can repeat it and we can track what is changed. But 100% automation? No. No. We like automation with approvals, which means that someone in the team has to approve something. And then we release the artifact to different environments. But the previous workflow, I already mentioned this, so we can be pretty quick about this. There was a build that someone built on a computer, shared it, or there was a manual database deployment. There was a manual altering of configuration files. And the approval was sometimes a phone call, sometimes a direct message, sometimes a letter. No letters, but it was informal, so there wasn't. And the biggest change we made as a team is going from shared environment to a personal environment. So we wanted to use this parallel working with Git also in this phase. And that's why we started using personal disposable environments. And we implemented the pull request workflow, which we'll come to in more detail later on. So first, we started using cloning. Again, another Redgate product, not a sponsor. But there are different technologies to do this. Cloning can also be done with containers. And cloning means that you take an image of production or whatever database you want, and that image you will use different times as a clone, saving space and time. We used SQL clone for that, and we automate everything we could, including the creation, but also the housekeeping. And all the developers didn't even know it was cloning. The only thing they did, they created a work item, just like I did in the demo, and they released the work item, or actually they released the build artifact, and then in the background, their personal environment was provisioned with the database, and if they were doing something else on their personal environment, because we like to work on different projects at a time, not that we like that, but mainly our manager says, you're working on project A, switch to project B for a minute, please. Well, if you switch from project, then your database is just for project A. How do you do that? We created database stashing, which meant that everything we were doing was automatically hidden, like the squirrel. Just with his nuts, he will just hide them somewhere in the woods. And whenever you change back to that work item, we will show you the database again. Sounds fancy. It was just renaming it to database underscore your topic you're working on. But then automate it so you won't see it. If you want to know if you want to know more about that, this QR code will go to an article I wrote about it. The presentation will be online, and if you don't, I think I already shared it in the Huizer app, so you find it or just ping me. It's on the Redgate website because I write articles for them. Everyone got it? So, clicker still working? The demo. So these are these releases I was talking about, and I will make this a little smaller. Is it visible for you, or I'm standing in front of it? So, like I said, this is production. So Sprint 164 is deployed to production. But here you see a little icon, which is the approval. So whenever a database change go to production, there's always an approval of the customer, because releasing the database code is good, but there's always a software side of it. So you have to release it just in time with the software. And if you look at some of the logging, I will open a task. You will see, for example, here the flyway migrate databases.ps. So again, this is one of the PowerShell files we included in the build artifact, so we can leverage them during the deployment phase. Simple as that. And since I'm 10 minutes out, I won't get too fancy with the demo here, but as you could imagine, I can create a release here. And recently the team changed the environments. I was not involved, but I understand why there are 5 separated environments here. And that's because they are now working with a different team that is doing the same changes parallel. So they're not connected. Usually you see connections between a pipeline, but this is an exception. But if I release my artifact, so I have here my topic SQL 2005. Whoa, I'm 20 years behind, I see. But you look at what I mean. I can create it, and if I open it, you will see that the artifact here is just the artifact we created during the build phase. And if you see this name, it's actually the same name everywhere, because of the naming convention that's not only applicable for the branches, but we also do that in the build artifact. So whenever you get a build, or you get an executable, because all the executables will also be tagged with that name, you can always go back to where it started in Azure DevOps. I promised also the pull request workflow. So we went from manual to the pull request release, which had a little implication, which was an advantage for us, but we didn't know about. So Microsoft has on its website, and I will click through so the QR code is already visible, has a learning page on what this means, the pull request workflow. But it meant for us, for the .NET code, but also for the database code, that it's always a build that includes whatever is in master, including what you're doing in the topic. So if your colleague already merged another topic during the test, you'll also see his work. And why that's important? It's important to prevent any merge conflicts up front. And the other thing we found very handy in this pull request workflow is that we could include a lot of automation. So we could tie the state of the release to the state of the pull request. So whenever someone approves the release, the pull request will be finished automatically by just checking the states. And there was a diagram here, but I removed it because it had too much details, and normally I'm almost out of time, just like now, 8 minutes. But the important thing in the diagram was it's good to automate, but still communicate with all your team members. So don't rely 100% on this automation. Also rely on the human factor within your team. So that's the main takeaway from that diagram that's missing. So we're now testing in parallel because we're working with the cloned database environment. We can just throw it away when we're done because it's just clones. And we implemented the pull request workflow. And with that, we could check all the 3 deliver practices that Microsoft wrote down on its website. And then it's already time for the operate phase. And the operate phase is interesting because I told you at the start of the presentation, no one alters production, right? And with the look of your faces, I think there are some people here who came across people that know a friend that alters production, right? No one alters production. But we have to monitor this. We have to be sure, because if we rely on this version control system, if we rely this is what is really going on, but someone is altering production, version control is wrong. So we have to monitor this. And another thing that's very important in the operate phase is securing your knowledge. So everything we know, everything that's in my head, everything that's in your head needs to go in a system. And that's even more important these days with large language models and AI, because everything that's in there, and it's good data, it can be used for other projects later on. So the troubleshoot. It's always important to know what has changed, who signed off on this, and where did the change come from. But those three things we can already check because we have approvals, so who signed off for this. We have work item linking, so that's easy, but not for those monitor changes. No, sorry, not for those production changes. So what we did in every delivery, we make a snapshot of every time we deliver the database. And we store that snapshot so we can compare it every night with the snapshot we make again. So if something is wrong, if something is changed, this nightly check will see this. And
do you snapshot the data as well?
That's a good question. Do you snapshot the data as well? No. So it's not a SQL Server snapshot. It is SQL Compare snapshot, or SQL Snapper is the official tool that's doing that in the background. And it's again a Redgate tool, not a sponsor yet. And that snapshot is just the structure of the database, so no data. But when that structure changed, we want to know this. So we create a work item with the SQL Compare report, and we put it on top of the sprint as a bug. So next time when the team comes in, they see a new bug on top of the sprint, and they check the SQL Compare report. Clicker? Yes. So this is the diagram which I kept, which is pretty complicated, but you will see it later on in the presentation download. But it actually has 2 starters, so at 2 a.m. in the morning or whenever something is deployed. Then the Snapper tool will run and make a snapshot of the database. And if it's post-deployment, the snapshot is always the latest one. But if it's not post-deployment, then we're going to check, is there a previous snapshot? Yes. We compare it with SQL Compare. We create a drift report, and we will notify the team. Easy as that. We invented this, snap and drift. It's a trademark. And then Flyway came up with a drift keyword. So still some lawsuits going on, but I think we're going to win it. So I'm pretty sure about this. Not a sponsor. Troubleshoot. So what's changed? Which kind of is where the change comes? Well, let's go on because 4 more minutes, 3 more minutes. How did we secure knowledge? What do we do? Well, it's actually simple. We encourage to document everywhere. Of course, a structure is very important, but if your requirements are not that good, like the online question was, document your requirements better in the work item. That's step 1. Because everything you do in Azure DevOps is searchable. But we also enforce this linking. So link all your resources. If you create a wiki article, for example, in Azure DevOps, you can link it to a work item. It's pretty easy. Just use the hashtag or the linking page on your work item. And if you have a SQL Server database and you just happen to have SQL Doc, another Redgate product, I won't say the other word, you can create all this documentation into a wiki, which is searchable again. And here's the searchable part. Because Azure DevOps is somehow using a pretty fast searching engine. And I was told it was Elasticsearch, but last time I got a remark from someone who said it wasn't Elasticsearch. I don't care. It's a good search engine and it works. And it searches through your code, through your wiki, through your work items, everywhere. So that's the way to secure knowledge. Write everything down. That's it, actually. So the key takeaways. People, processes, tools, in that order. It's the standard DevOps thing, but it is really true. Talk to your people, look at your processes, see how you can improve them, and then implement tooling for that. And do a DevOps of your whole team. So don't look at database DevOps only, because if you don't have your whole team on a proper DevOps, database DevOps will never happen. And then it's time for some questions that might be still there or not. We have a question.
I have a curiosity, because you showed the dashboard within the DevOps, and I believe it was for the personal use or within the team perspective.
Yeah. So was the dashboard that I shown personal or for the team? So that was my personal dashboard, but I can show you other dashboards for the team as well.
Yeah, but what I meant was, do you work with that personally, or did you review your work items within the team? Plan ahead.
So the question is, do you work with the dashboards personally to do your work or with the team ahead? So there is also a daily dashboard which is used during the daily stand-up. So I opened this one because I'm very interested in what work items change, what build failed, but the daily dashboard is more like what you've been working on, what's still on your agenda. And we have to stop. So thanks to sponsors, and don't forget the Wova app, scan the QR code and be happy. Yes. So do I still need to repeat it? Yeah, because I got to. Yeah. So the question is with the snap and drift. So the schema comparison, which is in a snapshot. What is the procedure when there's a drift found? So let's first start with we store the snapshot only once. So we store it whenever there's a new deployment or whenever there's a drift found. Because the next night, the drift is still there if someone didn't fix it. And we don't create a second work item. Because this new work item that's created the previous night needs to be fixed as soon as possible. because it can interfere with a change that's already somewhere in the pipeline, because it's altering an object that's already in topic C or whatever. So fixing the drift is a priority for the team. And that's why we only snap it once, and we don't get any repeatable work items or any how you call it, notifications extra on it, because the team is focused on getting all the bugs out of the sprint, because they're blocking the work that's already planned. The question is, do you use DAC-pack deployments? Oh, that's another question. So the question is, what do I think about DAC-pack deployments? So I'm a migration guy, and DAC-pack is more state-based. Some projects DAC-pack can be used for. I actually did a pre-con with a guy from Belgium, which was a kind of a fight between migration-based and state-based. And we did it the whole day. And the end goal is actually, it depends. So it depends on what kind of project you have. But for me, migrations are more important, because it will stack on each other what has been changed, and the migration file is created early on. But with a DAC-pack, it's last minute checked and compared, and then the migration file is created. And it can be handy in some teams, but not on my watch. Other questions? Yeah, because we're working with the Flyway desktop workflow, we have both migrations and state, so we can still use, for example, a large language model to do changes on that. That's absolutely true. It's interesting, actually. Yeah, talk for next year, yes. So now I have to really stop. Or there's an online question. Oh.
So the question from online is, where to seek knowledge considering CI/CD?
Where to?
Where to seek knowledge about continuous integration, continuous deployment?
Oh yeah, so what sources do I recommend for continuous integration, continuous deployment? Well, I uploaded some articles to Wova, which helped me. I will upload some more. Microsoft has a good learning page, and if you look up AZ400, it's the Azure DevOps certification. It's 400, is this? No, 900 is the fundamental. So yeah, so you can learn the basics there. So that can be an interesting source. But if you're not using Azure DevOps, then of course AZ400 is not for you. Come to a conference and come to sessions like this, then it's also a good source.
When developers work on this repository, they have to make two SQL scripts, one for operations and one for schema models. Work product from them is two SQL scripts for one change, or you use something like automation.
Yeah, so are we still online also?
Yes, we are still online.
Okay, so the question is, what kind of tools or scripts do we use to make this change, and what does the developer use? So Flyway Desktop helps you with that. So the developer will start within SQL Server Management Studio or Visual Studio Code, and will make the change directly to his development database, because it's personal. And then the Flyway Desktop tool will signal that change and will put the change into the schema model. That's step one. And from that step, he will commit his change and will let someone else review that change. And if the review is approved, then a migration file is created. That part can be automated, because if the pull request gets an approval, so it's not a completion but an approval, it can generate a migration script. So only one should be manual, but it can be both. Flyway Desktop, yes. It's from Redgate. You know this? Not a sponsor. So it just happened to be that the guy in the back just happens to work there, but it's just a coincidence. Not a sponsor. Thank you.